What are alternative stable states in ecosystem succession? Imagine walking through a forest or a grassland and wondering why some areas look so different even if they are in similar environments. Sometimes, ecosystems can settle into different stable conditions that last for a long time. This idea is called alternative stable states. It means that ecosystems can exist in more than one way, each with its own mix of plants, animals, soil, and climate. These states are not just temporary. They can stay stable for many years unless something big happens. In the process of succession, ecosystems change gradually over time. For example, after a fire or a flood, a barren land might slowly turn into a forest or a grassland. Usually we think of succession as leading to a single final community called the climax community, which is the most stable and mature stage. But with alternative stable states, it's different. The same area could end up in a different stable state depending on what happened earlier or what disturbances occurred. For instance, a pond might become a marsh or a forest, both of which can be stable. Once the ecosystem reaches one of these states, it can stay there for a long time. Small changes might not cause a shift, but if a disturbance crosses a certain threshold, the ecosystem can suddenly switch to a different stable state. This is called a state shift. Understanding these stable states helps us see that ecosystems are not always predictable. Sometimes, restoring an ecosystem after damage can be tricky because it might not return to its original state. Instead, it might settle into a new one, which can be harder to change back. This is called hysteresis, meaning the path back to the original state is not simple or direct. Knowing about alternative stable states is important for managing ecosystems. It shows us that small efforts might not be enough to change an ecosystem's condition if it has already shifted into a different stable state. It also helps us recognize that ecosystems can have multiple ways of existing, and that disturbances can push them into new, stable configurations. This understanding guides conservation and restoration efforts, helping us protect the diversity and health of ecosystems over time.